All right, we're going to look through the process of measuring a rotor and then machining it, determining if we have enough material on the rotor to be able to resurface it. So your choices are either resurface the rotor if you're going to put new brake pads on, or replace the rotor with a new one. Some shops don't have the machine that we're going to show you, so their policy is just to replace every rotor. But in the long run, that can cost the customer a lot more money, because they're going to charge them for new rotors and mark that up, and then ultimately cause more money that the customer has to spend. So we're going to show you how to resurface the rotor. So first thing you need to do is either look up or find the minimum thickness specification. If you look inside the rotor, on some manufacturers, they actually put that specification in there. You can see MINTHK, that's minimum thickness. And then if you look, you'll see a 24.75 mm. So that's 24.75 millimeters. So what I did, the tools that we're going to be using to measure the rotor are in standard sizes. They're English. So this micrometer here is the tool that we're going to use. So what I need to do first is convert this 24.75 millimeter to inches, so I can use this micrometer. They do sell metric micrometers. I'm more used to using the English micrometers, so we can do it either way. So we'll be using the English micrometer for this demonstration. So I'm going to just write down on a piece of paper, 24.75 is our minimum thickness, THK specification. Okay, minimum thickness, and that's in millimeters. Now, one of the numbers that I want you to remember is 25.4. 25.4 millimeters equals exactly 1 inch. Now, if you know that 25.4 millimeters are in 1 inch, you can divide one into the other and find out how many inches 24.75 is. So if we take 24.75 and divide it by 25.4, okay, I did that with a calculator, and it comes out to 974 inches. Okay, so this number right here is the same as this number right here. The only difference is one's in inches and one is in millimeters. Now that makes sense, because if there's 25.4 millimeters in 1 inch, 24.75 should be less than an inch, and 0.974 is just slightly smaller than 1 inch. Okay, so I think we're going in the right direction, just to verify that. Okay, the next thing we want to do is we're going to get the right micrometer. These come in all different sizes. If you look at the bottom of the micrometer here, you'll see this is a 0 to 1 inch, and it measures in 10,000ths of an inch, which we'll explain. We have a box over here that if you need a larger micrometer for measuring larger components. This particular micrometer here, this box is full of different sizes. This is a 1 to 2 inch micrometer, as you can see. So it can read anywhere from 1 to 2 inches. They go up from there. This one is a 2 to 3 inch micrometer. So if you're measuring like the size of a piston or something that's bigger, on a little engine, the piston will be somewhere between 2 and 3 inches. This will measure that. Car piston, you might need even a larger micrometer. This one will measure from anywhere from 3 to 4 inches. And we even have bigger ones than that. These I haven't really used yet, but there would be like a 5 to 6 inch micrometer here. So this is a real big one. So again, the idea is to get whatever your range that you're trying to measure. In this case, 0 to 1 inch will fit. If it was a thicker rotor that was, maybe the specification was over 1 inch, but under 2 inches, I would use the next size up micrometer, which would be the 1 to 2 inch. All right, so this one's gonna work. So I'm gonna just stand this micrometer up so we can measure the thickness. And again, we're measuring basically how wide this part is. So I'm gonna take the micrometer, and you wanna put it around the outside of the rotor and just tighten it up. The way you tighten it up is you turn, let me see if I can show you this. This part right here, you're gonna just spin this, and what they recommend is you tighten it up by this end piece here, which will prevent you from over tightening the micrometer. And I'll show you what I mean in a minute. If you tighten it up strictly by this part here, you can actually over tighten it. Like if you start tightening it too tight, you can actually tighten it too much. This little thing here is kind of a little ratcheting mechanism that won't allow you to over tighten it. So just keep that in mind. Let's take a look and see if we can see the scale here on the micrometer. Now, I don't expect you to be an expert on reading using the micrometer yet. Later on, when we meet in person, we're gonna have some practice time using this tool. So let me see if I can kind of give you a quick lesson. You're actually gonna be adding 4 numbers together. The first number that you're gonna add in this case is the low end range of the micrometer. So what is the range in the micrometer? It's 0 to 1 inch. Again, that was printed on the micrometer. Again, on the this side there, it's upside down, but 0 to 1 inch. So what we're gonna do, on my sheet, I'm just gonna add 4 numbers together. First number I'm gonna add is the low end range of the micrometer, which in this case is a 0. So I'm gonna put 0, 0.000, which represents the size of the micrometer. That's the low end of the micrometer. If it was a 1 to 2 inch micrometer, I would have wrote 1.000. If it was a 2 to 3 inch micrometer, I would have wrote 2.00, and so on. The next number that you need to look for on this scale is these numbers right here. As you can see, you see a 0, 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 9. And what that represents is tenths of inches. So that would be 1/10, 2/10, 3/10, 4/10, 5/10, all the way up to 9/10. So I can see the 9, but I can't see any further than that. So I'm gonna write on my sheet 9/10. The way you write that is 0.900. I'm just putting the zeros after that to keep everything lined up. Next thing I wanna look at closely is how many little lines do I see past the 9? And if you look closely, you only see one line. This small little line right here after the 9 is the only line I see. But realize that the rest of the lines after the 9 are being covered up right now, because there's actually potentially 3 or 4 different lines that you could see after each number. But because this part is covering it, the rest don't count. So that one little line represents 25 thousandths of an inch. Each line, if there were 2, we would add 2 25s, and that would be a 50 thousandths. If there were 3 lines, we would add 3 25s together, and that would be 75 thousandths, and so on. So in our case, because we only have one line, that's 0.025. That's how you write 25 thousandths. 0.025. Okay, so that's our third number that we have to add. The last number that we have to add is the part that I was spinning to tighten the micrometer stopped because it was tight around the micrometer. And this scale right here spins with this part as I tighten it. And what we want to do is see where that stopped in relation to this horizontal line right here. If you look, there's a horizontal line. And if you go across, it looks like it just stopped right on that line right there. And that represents thousandths. So if you have 10 here, that would be an 11, that would be 12, that would be 13. If you look around here, 14, there's a 15. So it looks like we landed right on the 13, because there's 10, 11, 12, 13. That's 13 thousandths. So what we would have to add to our total is 0.013. And again, that's where we got that. We're gonna add this together. That's 8. That's a 3, That's a 9. Okay, so what I'm seeing here is this is our measured reading, and this is our minimum, right? So I already see a problem here. If you look at our measured reading, it's actually smaller than our minimum. So basically, what does that mean? That means this rotor is too thin to be used on the car. It has worn down, the sides have worn down to the point where you can't safely use this rotor. We are going to show you how to cut it anyway, just as a demonstration, but in reality, this rotor can't be used because it's too thin. How do we know that? This is the minimum, 0.974, and this is our measured reading, which is 0.938. So it's quite a bit smaller than the minimum. So that means this rotor is way beyond service. If you put this on the car, you could potentially have a dangerous situation because brakes rely on heat dissipation. That's why there's fins on the middle of this. These fins actually try to cool it down, but if the metal part on each side of the rotor, the metal here is thinner than it's supposed to be, the manufacturer determines that it's not safe anymore, and that's when you have to replace it. So the new rotor was a lot thicker when it was brand new, and the rotor wore down as it got older. All right, so if we want to cut the rotor, just as a demonstration, even though this one is no good, we're just going to show you the procedure for cutting it. The rotor might have a surface that looks something like this, where it's kind of like a little rough. If you look at this surface here, trying to kind of zoom up to it a little, or even a surface like this. These are a couple different rotors that we have. This is very rough if you look at this, and if you put new brake pads on this, it's going to chew your new brake pads up and make them wear out really quick. This surface needs to look like a mirror when you're done. It can't be rough like that with all these little ridges. Okay, so what we're going to do is we're going to take this rotor over to our machine. This is our brake lathe, which you guys are going to be using. First thing you're going to need to do is we need to center the rotor on the machine. So what we're going to do is we're going to take off these adapters. We're going to find a cone that's going to sit right in the center of the rotor. So we need to find one of these centering cones that are going to fit in the center. So we're going to look for the right size. We have a couple different sizes here. It looks like a little bigger. Okay, this one's still too small, so we're going to go up a little higher. Let's see what we have. Okay, here's another one. Okay, so this one looks like it's going to work, because if you look at the size here, it fits like right in the middle of that, and it's going to center the rotor on the machine. Okay, so what we need to do is we're going to sandwich this rotor in between two heavy metal adapters here. These are to absorb some vibration when it's actually cutting. So we're going to put this on the machine first. Okay, this is going to fit on there. We're going to put a spring in between the adapter, the little cone, and the heavy metal adapter. Again, this was the one we picked because it fits right in the center of that. We're going to put this on here. Okay, and that's going to push up inside our adapter. Next thing it's going to go on is our rotor. Okay, so we're going to put this on. This is going to push up against the adapter. Let's see if we can get that better here. All right, so we'll put the spring in there. Adapter. Put the rotor on. Okay. And then the last piece is the other metal adapter right here. This is going to fit on the outside. Basically, we're sandwiching the rotor in between these two metal adapters. Now what we need to do is take up a little extra space here because we need to put a threaded nut on the end of that shaft. So we're going to put this on. This is basically just a spacer. Put another spacer on. Okay, like that. And then we're getting closer to the threads. And then the last thing is the nut. So put that on. Okay, what's a little unique about this nut is it threads backwards. So it's actually tightening up. Instead of lefty-loosey, righty-tighty, it's actually backwards. Because the way the machine works is if you had the threads going the other way, it would unthread itself when it was operating. Okay, so what I'm gonna do, when I put the wrench on here, I'm gonna pull it down and then jerk up on it real quick. And that just snugs up that nut there. That's all you have to do for that. I'm just gonna turn the machine on for a second just to make sure everything's spinning straight. In the back here, you'll see a little switch. Okay, we turn that on and you can see how the machine works. Okay, so it's just spinning around right now. Now, before we actually cut a rotor, we have to put a damper on the rotor to keep it from vibrating. This is the tool we're going to use. This is kind of like a spring thing. This is going to go around the outside of the rotor. So we need to stretch this. This is going to sit right in this groove right here. Let me put the phone down for a minute. We're just going to kind of stretch it around the rotor to make it fit. So let me see. I'll show you what it looks like after we get it on there. All right, so simply you just have to stretch the spring around the outside like that. And what it does is it absorbs some of the vibration as the rotor's cutting. Okay, next thing we need to do is turn the machine on. Make sure everything's straight. Now these are the two cutting tips on the brake lathe. We need to make sure that those two cutting tips are centered with the rotor in the middle. And you can see it's pretty close. If we had to make an adjustment there, let me just shut the machine off for a second. This bolt right here, you're gonna use the other end of the wrench and you're just gonna loosen this up if you need to. And what you can do, once that's loose, is you can slide this one way or the other. And the idea is to get it so the two cutting tips are pretty much in the center, just like that. Okay, then we're gonna snug up the nut with the wrench. Make sure that it's tight. Okay, so we're just gonna give that a pull. Okay, that's good there. Okay, next thing we're gonna do is we'll turn the machine on again. Okay, what we need to do now, there's this one knob here on this side. You can see where it is. This is gonna allow us to move the cutting tips towards the rotor. As you can see, it's getting closer and closer. I'll go up here. And this actually moves the two cutting tips towards the rotor. So we want the two cutting tips about in the middle, as you can see on the side. Okay, I want the cutting tip about in the middle of the surface. Now what I'm gonna do, I need to get it so the cutting tips are just touching the rotor. So if I turn this knob right here, we have to unlock it with this little lock here. Just make sure that's loose. Okay, I'm gonna turn this until I see, as I turn this, it's getting closer and closer to the rotor. So I just kind of want to watch this as I'm getting there. When I'm getting close, you're going to hear it hit. So you want to slow down when it's real close, and you'll hear it just touch that. Right now it's just touching it. Okay, I want to lock that in, so I'm going to tighten this up. That's going to keep it from moving. I want to come over here now, and I don't want to turn this part right here, which is the part that I just was turning. I want to turn this knob right here, which is going to let me zero this scale right here to 0. Okay, as you can see, there's numbers on here. So you want to bring this around. There's 2 zeros. You don't want that 0 because these are not the numbers that we're interested in. If you come around to this 0, these are the numbers. These are 10,000s, 20,000s. These are the numbers that we want. So we're going to start right at this 0 right here with the 10,000s to the left of that. That's where you want to start. Okay, I'm going to do the same thing with this one now. Make sure this is loose. Again, you can watch what's happening here as I tighten it up. It's going to get closer and closer until it just touches. Okay, so it's just touching. Okay, we're going to lock this in, and we're going to come back over to this scale, and the same thing. I'm going to turn, not this part, because that's the part that moves the bit, just the scale with the numbers on it. I want to bring that around to 0, but I want the 0 that has the 10,000s to the left of it. So that's, all right, let me bring this all the way around again, because there's another 0 here, but that doesn't have the 10,000s to the left of it, so that's not the right 0. You're going to bring this around until you get to the 0 and just double check that the 10,000s is to the left of it. Okay, so this is ready to go. So at this point, what I want to do, let's just double check this one here for a second. We want that just a touch. Okay. We're going to 0 this. That looks good. All right, what we're going to do is we're going to back off on the lock, which is this right here. And I'm going to turn this to the left, which is going to take the bit away from it a little, just the outer part. Same thing on this side. I'm going to turn this to the left just a little to back the bit away from the rotor. Now I'm going to carefully turn this knob right here until the cutting bit is as far in as we can go where the brake pad rubs. This is going to come all the way in here. Okay, you got to be careful now that you don't hit, they call that the hat of the rotor. So I'm into some metal right now where the pads never ride. So I'm just cutting into that a little. All right, so I'm going to leave it there. You just want to be careful that you don't hit this part of the rotor right here, which is the hat of the rotor. Okay, this is the hat. You want to make sure you stay away from that. All right, now what we're going to do is we're going to dial back into 0 with this, turning the outer part. Okay, I'm going to dial into 0. And I'm going to add 8,000 right there. And I'm going to tighten that. This side here, same thing. I'm going to dial it back to 0. And I'm going to add 8,000 and then tighten that up. Okay, that means I'm going to be taking 8,000ths material off each side of the rotor. That's what's going to happen. Now, how do you get that to happen? This lever right here is the control. If you look on here, it says fast, slow. If I lift this up and move it this way, it's going to automatically feed the cutting tip fast. If you look at this here, that's turning by itself. That's because that lever there makes it feed by itself. And if you look at what it's doing right now, you can see it's actually shaving off material off the outside of the rotor. And it's making it nice and shiny looking on both sides. You can see the other side here. Now these little metal filings that are flying off this right now, they're hot, and you need to have safety glasses on. You can see we have a catch thing here, and down inside here, all the little metal filings are falling down at the bottom there. All right, so we're going to let this continue through to the end. I'm going to stop the video here, so when it's done, I'm going to show you the final step.